Seeking English S.A.T. Workbook, page 440, problem 4. This is one of those videos where if it doesn't work perfectly, I'm probably going to stick with it, just because so much can go wrong trying to film this particular problem. This problem confuses students a lot, and it was a little bit confusing to me at first, but usually when a problem, most of the problems the first time I went through this book, if something was a little confusing to me, there was usually at least one student who nailed it right away and wasn't confused at all. This problem, I think, has been at least a little bit confusing to every single student so far, and it's been a few years. So I think one reason is that the problem just isn't set up the way that most math problems are set up in most high school math textbooks. So I've tried to put a little bit of extra stuff on the board to try to explain this problem a little bit more clearly. And there's a weird thing that happens in the problem that you might think, no, I'm not supposed to do that. Well, you are and you aren't. I'll show you why. It says p of x is a polynomial and the value of p of minus 4 is 7. Which of the following must be true of p of x? The word must is crucial because, as I'm going to try to show you, some of these answers could be compatible with whatever the polynomial happens to be, but we don't have any means to conclude with certainty that it is consistent or with the polynomial in question. This problem is not a matter of eliminating things that are wrong, but it is a matter of eliminating things that are uncertain. So those of you who are hoping to go on to law school at some point after taking the S.A.T, pay special attention to this problem. This is a good mental exercise for people who are going to get into things like litigation later. Okay, if it's not certain, we take it off the list. This problem is about certitude. Okay, so it says first you have two. These are comparatively simple, and so I'm going to deal with these two first. These two are comparatively complicated, and I'm going to deal with them. But I'm going to deal with all four answers. Don't worry about it. I'm going to do all four. Okay. If x is minus 4 is a factor of p of x, if this were certain, then we would know that if we plug in this minus 4 here, that we get 7 out. Now, if we plug in the minus 4, we get minus 8. Now, there is a number, a real number, by which you could multiply minus 8. Okay. If this becomes, say down here, I put this here twice for a good reason. You can see it. Okay. So if this becomes minus 8 and this is a 7 over here, okay, there's a number here we could multiply by minus 8 in order to get the 7. But we are not given any means to conclude that this other expression is going to give us that number if we plug in this minus 4. I know, but we could do that. I know we could calculate what that number is, but we don't need to do that. Don't calculate it. All we need to know is that we can't be sure that that's going to work. Okay? We don't know what this other expression is. Okay? We don't know if we're going to get a 7 because we don't know the other part of the polynomial. We just don't know. Okay? We just don't know. Okay, so that is gone. Here, x plus 7. Similarly, we plug in this minus 4 and this plus 7. You get a 3. Okay? 3, and you get a 7 over here. Again, there's a number that you could multiply by a 3, okay, in order to get a 7 here, okay? It's 3 times something equals this 7. And teacher, I know that number. I know you can give me that number, but I'm not asking for it. I'm making a point of not asking for it. And if you're calculating it right now, don't do that. Don't do that. You're wasting your time, okay? Because we simply don't know what the other expression is here. We don't know that if we put in this minus 4, we would get what we need. 1 multiplied by this 3 to give us this 7. We don't know that. Okay, so that is, bring this back to 0 for a second. Okay, so we don't know that. That's gone. Now here is where I need to show you both of these. What is a remainder? Okay, a remainder is what prevents something from being equally divisible. Meaning in terms of simple division. In a polynomial, it means that it prevents you from getting a 0. Okay? If you take the expression apart into these two things, and you don't get a 0, you get a 7 over here, means that 7 is a remainder. Okay? 7 is your offset from a simple division of the polynomial into those two factors. Okay? You take a polynomial and you factor it, and there's some junk left over, that is your remainder. Okay? I hope I'm explaining this in a way that is clear to you. So these are gonna become two versions of this. Okay? There's our 7, okay? And that means that you don't get a 0. You just don't get a 0. You get a 7 because of this remainder. That's the difference between, okay? It's the difference between simple factoring and something else. So what would happen here? If we put this minus 4 in here, okay? This becomes a minus 8 again here. Okay? And again, we don't know. We don't know. If we say the 7's a remainder, I'm going to say that we do this. We should get a 0 except for the 7, so I'm going to put in the 0. If it looks weird, yeah, I know it's weird. This is a weird problem. If we put in the 0, we should get a 0 out of this side here. And then just remember that actually, no, it's actually a 7 over there because of a remainder. Okay? It means if you took out the 7, you would get a 0. It's weird, I know. Okay, so here, again, you get this minus 8, and down here you get this 0. Okay, now I know the way I've written this here is not the way they've written in the book, and so the way I've written this here makes it look like I'm asking you to divide by 0. But division and factoring are not exactly the same, and I want to make this point very clear. Division and factoring are not exactly the same. Okay? When you factor a polynomial, you actually are breaking it into two things, one of which should be a 0 some of the time. Okay? So you're not exactly dividing by 0. You're breaking a thing up into two parts, one of which some of the time has to be a 0 in order to get that 0 there. Or in this case, the 7 because the remainder. I know. It's so complicated. It's so complicated. But don't worry, you're going to get it. Okay, you're going to get it. If you don't get it the first time, watch the video again. If you don't get it the second time, put it aside and come back to it. Okay, this is a difficult problem for me to explain, to be honest with you. There's probably someone who could explain it better than me. Good luck finding that person. This is a weird problem. Okay, so what we want is we cannot be certain that this would produce a 0. Okay, in order to explain that 7 when we put the 7 back in. We can't be certain. And so it's similar to what we had before. Down here, yes, we can be certain that this will produce a 0. Okay? So regardless of what that other factor is, we should get a 0 except that we have this 7 instead. Now, why would they do this to you? Why would they do this to you on the S.A.T? Well, because they can. Okay? There are, just as there are some problems that are oddly too simple. They seem to be used to divide first percentile by second percentile. There are some problems that are there to divide 98th percentile from 99th percentile. So they get the nice bell-shaped curve that they want for student responses. I think that's the curve that they want. And so introducing this 7 to you and framing the question in this way takes what otherwise could be considered a pretty transparent problem and making it seem a lot more complicated than it is. I could rewrite this problem so that it is half as confusing, but then I wouldn't be accurately representing what you're going to be faced with on the test. Just as it's almost inevitable that you're going to find one problem on the test that seems like it's way too easy, you're probably going to get hit with some other problem that is, if it's not actually complicated, it's just confusing. Okay, they may use various types of confusion to make what is actually not that complicated a math problem seem more complicated than it is. And is that fair? I don't know. But it's a statistical tool that if you simply want to get that curve, introducing or removing various elements of difficulty from the test design allows you to get that curve. And then you can debate with the rest of the design team whether you're really testing somebody on mathematical ability or some other thing in that particular problem. I don't know. So I'm trying to not wax cynical about this problem right now. I want to be clear that if it sounds like I'm being cynical, it's not that I'm being cynical about this problem. I'm being cynical about the test itself, and for that reason, you must have a problem which matches the test in terms of how it is going to be difficult for you.